All right, so last one in the group. This one's a little bit of an interesting question because it has some interesting conversions built into it. So if we look at our units so far, the only thing that matches and really looks very nice is that this has got per second and the other thing's got per second. That's great. But then when I look at centimeters and liters and meters, and none of it really goes together. Um, I also we've got diameter here. I don't know right offhand whether diameter or radius is better. You know, a lot of times we're dealing with a circle, we've got to convert between one part and the other. So let's just look at the formula and see where it's going to go. So the velocity of a fluid in a pipe, or coming from a nozzle, end of a hose, whatever, is going to come from the flow rate, which is Q. Not quite sure why it's Q. Maybe that's like the quantity of material per time, something. I don't know. But is the flow rate divided by the area of the pipe. So if you were to take a tiny thin slice or look through the end of a pipe, that's called the cross-sectional area, and we're looking at that shape. We can do a little bit better here though, because pipes and hoses and nozzles tend to be round, and so we can pretty safely assume that the area is going to come from pi r squared. So that's enough now for me to start figuring out what's going on with the rest of the stuff. We've got Q, that's the flow rate right here. I want R, so I want to remember that the radius is only halfway across the circle. So I take my diameter and I cut it in half. So I divide that by 2, then I get that my radius is 0.61 centimeters. Now, that doesn't fit with the meters I'm eventually trying to get, so I want to go ahead and also fix this. So remember, as we've seen a few times, 100 centimeters is a meter, and that's going to give me this radius is 0.0061 meters. Now, when I start plugging into this, meters look good, but we've got extra units. We've got these liters that need to go somewhere or leave somehow. But if we start plugging in, let's just kind of see what happens, and maybe we can figure out a way to fix it. So a little bit weird to have units stacked inside of a fraction, but that's okay. Pi is just some number, so it's not really going to get in the way. We do need to remember that this radius is squared, so don't drop the exponent there. And so the per second's fine. The meters are actually in the wrong spot because they're down on the bottom, and we want them up on the top. And so we pull one last trick here. Liters can be converted to several other things like milliliters and cubic centimeters and lots of other stuff. But our most handy trick here, put liters on the bottom to make that part cancel. Liters can be converted into cubic meters. And that's actually more helpful than it seems because the liters will cancel from the top and some of these meters will cancel with the bottom, and that's actually going to get us in the right direction. So 1 cubic meter is 1,000 liters, and that should be on your formula sheet. If we check through the units, the per second again is fine. The liters now are going to cancel with liters. Meters here get squared, so they're going to cancel out with the exponent and leave meters. And so it's a little bit weird that the meters and the per second are separated from each other, but together they do actually make the units we want. So on the top, we still have just 8.79 because it multiplies by 1 and nothing really happens. Across the bottom, pi times 0.0061 times 0.0061 times 1,000 gives us a number because pi is involved that goes on and on forever. Meters per second are the leftover units, but I look, well, that's obviously not the final answer. It's in fraction form, so that means I can divide it and get it down to at least just one number instead of 2. And I get something around 75.19 with the meters per second from earlier.